talking about the action of adding, the action of subtraction, the action of multiplication. We've been putting them together with story problems and math stories. And then when we've been working with just the symbols. Something you need to know today is they use the word operations. And if you've ever been to the doctor, have you heard the word operation before? An operation is when they go into your body and maybe change something. Like maybe they fix your knee or they fix your heart or something like that. They change something. Well, when in math, when you're changing a number, when you're changing something around, they call it an operation too. So what's an action in math that changes a number? What's one of those math actions that we talked about? Bella, what's a math action? What's one of them? The act of doing what? Okay, so what is that called? Addition. So addition is an operation. It changes a number. What's another operation? Yeah.
Subtraction with like that comparing. What's the act of removing?
Yeah, or comparing could be the operation. It's the act of changing a number by comparing or removing something. What's another operation in math?
Dividing.
Dividing, which we haven't really talked a lot about, but it's splitting it into equal groups or scoops of the same number. Yeah.
Multiplication.
And multiplication is the act of equal groups or repeated addition. So in surgery, it's the act of changing your body, hopefully to help you, and that's called an operation. But in math, we talk about an operation as well. So today, I want you to look at numbers and operations, and we're asking you what similarities and differences do you notice. We're going to give you 10 seconds to think on your own. But ladies and gentlemen, your eyes need to be up here to actually look and think. So 10 seconds to think on your own. We don't need any hands. What is similar and different between these two? Just want you to look. Turn and talk to your partner about what is similar and what is different.
Similar is the answer.
Expressions. I heard Elsa and Madison come up with some similarities. What did you notice?
Well, both of them have the same numbers and they both have plus names.
So there's a 1, there's a 1. There's a 2, there's a 2, there's a 3, there's a 3. So same numbers. They're seeing the same numbers in both. And then what did you say about the operations?
They're both the same, just in a different order.
Same numbers, same operations. What operations did they use?
Times and plus.
Okay, so multiplication and addition. But you did say something that was different. So it is the same numbers, same operations. What did she say about the difference?
So right there is 3 times 3 and it's 9. And right there is, altogether is 7.
So we're thinking the answers might be different. Someone said answers Are different. Okay, so maybe the answers are different. I heard somebody else say something different than that. Did you guys think the answers were different or the same?
We were thinking the same.
And then I thought it was different.
Yeah, like me and Jason thought we were the same answers. Like Hammer thought it was a different answer.
So some of us think answers are different. Some of us think the answers are the same. What's something else you can tell us about similarities and differences? So we're thinking maybe the answers are the same. Some of us think answers are different. We know the operations are the same in both. The numbers are the same in both. Sam?
The order's different. The order of the operations. It's
Okay.
plus, it's addition, it's the addition problem, and then the multiplication problem. Second one is the multiplication one problem, and then the addition one.
So different order.
And I agree with Cameron that the answers are different.
Okay. So we've got a couple people thinking answers are different. Yes.
I agree with Sam and Cameron because I think it's a different answer because the first one's 1 plus 2, and then the second one's 2 times 3.
So just depending on which way you're reading it, you might be coming up with some different answers.
Well, I think they're both the same because you have 1, then you have to multiply the 2 and the 3 to get that answer, so you can add the 1.
There's a lot of good thinking going on. People are thinking the answers might be the same, they might be different. Today, while we're learning, we're going to learn the importance of, you actually said exactly what we're learning, the importance of the order of operations. We're going to learn which way we should solve things and learn why it's going to matter. Do you think it will matter if you both come up with different answers and you don't know who's right?
No.
Yes.
Well, yeah.
If you can't prove why one is right and why one isn't right, if you don't have any models or any thinking behind it, people would just be like, well, I don't know who's right. We don't know what to do. So today, when you go with your partner, and I'll read who your partners are. When you go with your partners, we're going to be learning how to do the order of operations and what to do. And then when we come back, we're going to figure out, are these the same? Are they different? Who was onto something? Who maybe was like, I learned something new. So when you hear your partners,